Hey guys, this is Academic Chemistry, Chapter 5, Section 2, Part 2, Arrangement of Atoms. And you're going to need a few supplies today to help you out. So the first thing you need is your chemistry BIF, your best friend forever, which is your periodic table. The whole point of the lesson is to learn how to read the periodic table. And the other thing you're going to need is some coloring utensils because we're going to do a little color coding. So you're going to need blue, green, pink, and yellow, either a colored pencil or a highlighter. I recommend you do not use marker because then sometimes it's hard to see through it. So you want to be able to see through and still read your periodic table, or the one we have on our notes. So here on this slide, you see a big chart with lots of numbers, and you might be thinking, wow, Mrs. Dominiak, it looks an awful lot like a periodic table of elements. And you know what? You would be right. It does look a lot like a periodic table of elements. But today, we're not going to consider it a periodic table of elements. What we're going to think of it as is a periodic table of electrons, okay? We are mapping out all the total possible electrons. So the thing you have to realize is when you look at this, you're actually looking at how many electrons are in an atom. Let's get to that. The first thing we need to do is change a little bit of our periodic table. So for this lesson and for any electron configuration when you're using the periodic table, number 2 here, helium, actually isn't over there. Later it'll actually come back, but we'll get to that. It's going to be over here. So for the rest of the notes, pretty much helium or element number 2 or electron number 2 is going to be over there on the left-hand side. So what we want to keep in mind is the periodic table is actually organized by atomic number, which is the number of protons, right? So hydrogen has 1 proton, helium has 2 protons, lithium has 3 protons, and so on. Now we're going to be talking about neutral atoms, meaning they have no overall charge. So if they have no charge, then the number of protons and the number of electrons have to be equal. So that means over here, hydrogen has 1 electron. Helium has 2 electrons. And the thing about atoms is your electrons fill in very specific ways. So if an atom has 1 electron, if it's hydrogen, that electron does one specific pattern, kind of where it goes, right? Helium has 2 electrons. The first electron it has is exactly the same as hydrogen's electron. It just has an extra second one. Lithium, atomic number 3, a neutral atom, has 3 electrons. So it has the electron that hydrogen has, that extra electron that helium had, and then it has its extra 3rd electron that hydrogen and helium both don't have. And they follow specific rules. Any atom that has 3 or more electrons has that 3rd electron that lithium has that helium didn't have, and it's always doing that same thing, or found in the same locations. So for example, how many electrons does beryllium have? So I want you to find beryllium on the periodic table. Here it is. Beryllium has 4 electrons because its atomic number is 4, so it has 4 electrons. It has the 3 electrons lithium has, which is the one from hydrogen, the extra from lithium, or from helium, the extra from lithium, and then it has an additional 4th electron. So it has the 1st, the 2nd, the 3rd, and the 4th electron to fill. The first 4 electrons always fill in the same patterns for any single element that there is. So here they are, the 1st, 2nd, 3rd, and 4th electron. So here's where we're going to start coloring. So I want you to go ahead and pause the video, and all of these numbers highlighted pink, I want you to highlight on your page. Okay, so you should have this whole area highlighted. Anything in these 2 columns or these 2 groups are part of what's called the S block, meaning any of these electrons fill in an s orbital. All right, go ahead and color all of this green. So this green area is the P block. All right, what else is there? Over here, color that in blue. So that's the inner part. These are called your transition metals. All of your transition metals, make sure you color them blue, and that's the D block. And the bottom here, color all of this. These are your inner transition elements, and they are yellow. Please color that. That is the F block. So you should have all of these colored and matching, as well as labeled on your page. I also want to point out the numbering. So for this F block down here, it starts at 58 and 59. So let's find that here. We have 55, 56, 57. The next element actually is down here. So basically your periodic table opens up in the center. So right here, there's a giant rift and it opens up and that bottom part comes up in the middle. However, these elements were considered very rare. They're still very rare. They're not things you come into contact on a regular basis or deal with a lot in general chemistry. So if we put them in the center, if you opened up the periodic table, it would be super awkward. So we just take them and stick them on the bottom. But for most of electron configuration, you don't need to worry about them too much because they get kind of complicated, but just so you know, that's where they do fit in. All right, so what do these mean? So electrons are in orbits that match their block. So what do I mean by that? In what shape orbital would the 17th electron be? So find the 17th electron. You notice the 17th electron is in the p block. So whenever you're filling electrons in the atom, a 17th electron always is in a p orbital. All right, the other thing we need to talk about is energy levels. And those can be abbreviated N, like I say, what N is something, N means energy levels, and those increase as you go down the periodic table. So this is your first energy level, your second, your third, fourth, fifth, sixth, and seventh. Now there are some rules about energy levels. The D block is always N-1. So this is your fourth energy level across, right? Except for in the D block. So these are 4s, but all of these are not in the fourth energy level. It actually goes back one. So 21 through 30 electrons, those are in the third energy level because it's N-1. This is your N, 4, and it's -1 here, right? So like electron 43 is in the D block. So it's not in the fifth energy level. It's N-1. It's in the fourth energy level. The F block here, which remember squeezes in right here, uses the rule N-2. So these electrons, 58 through 71, fit right here. So that would be in the sixth period, or that's what goes straight across. They're called periods on the periodic table. But instead of being in the sixth energy level, you do 6 minus 2. So electrons 58 through 71 are in the fourth energy level. Now, when we did those diagonal patterns, you'll notice the filling pattern will match that. It's just using the periodic table to read instead of making those annoying diagonal lines every time and drawing that chart all the time. You can just use the periodic table. So let's figure out how to do that. Here's a little cheat sheet for you if you want to see what energy level and what subshell things are in. All right, so here are the steps to find an element's electron configuration using the periodic table. First, find its block on the periodic table. I'm not talking about S block, P block, D block. I'm talking about that actual block, like sulfur and its little square, the S. Next, you're going to read the periodic table just like a book. So you're reading left to right and top to bottom. So it's in numerical order. You're going to list the energy levels and subshells that you hit, like 1s, 2s, 2p, on your way to the elements block. So you always start at hydrogen, or 1, and then go to wherever you're going. And then you use the superscripts, those are up high numbers, to tell how many boxes are in that grouping. Let's just do one. Okay, hydrogen. Where is hydrogen? It's right here. So hydrogen is here. To start at the beginning, you just go to hydrogen. So it's in the first energy level, S block. So this is 1s. These two, 1 and 2, are part of energy level 1 and the S block. But how many little squares did you pass? Well, you only went through 1. So it's 1s1. Okay, let's do one a little harder. How about helium? Where's helium? So if you look on your periodic table that has the elements listed on it, you'll see that helium is atomic number 2. So you find where that is, and then you read across. So what little squares or blocks do you have to go through to get to number 2? Well, you're in the first energy level and you're in the S block. So you have to say, how much do you have in the first energy level S block? So I have 1s and I have boom, boom, 2, 1s2. And then you've got to your final destination. So you're done. How about carbon? So first thing, find carbon on your periodic table and then find it here. So this is carbon, atomic number 6. You always start at the beginning, start at 1. And you're reading it like a book. So you're starting way over in the corner and going across everything you have across, and then you go back, go across again. So first, to get to number 6, you have to go through 1 and 2. So if you have 6 electrons, you have to say where those first 2 electrons are. So they're in the first energy level in an S block. And how many do you have in the first energy level S block? Well, you have 1, 2 squares. So that's the number that goes on top, how many squares you have. All right, if I just have 1s2, have I gotten to carbon? Carbon's all the way over here on 6. After 1, 2, the next number would be 3. So you come down here. All right, I have stuff in my second energy level in the S block. So I'm going to write 2s. This is your energy level. This is the block, or what type of orbital it is. Then for your superscript, you say how many squares did you pass in that area? Well, in 2s, I had 1, 2 things. So I put a 2. I'm still not to element 6, so I have to go all the way across here. I'm still in my second energy level, but now this is the P block. So this is 2P. How many squares do I have in 2P? So this is my second energy level, 2P. I have 1 for 5, square 5, and my second square is square 6. So it's 2P2. So carbon's electron configuration is 1s2, 2s2, go over, and 2p2. Let's do another one. Selenium. Find selenium, Se, on your periodic table. And then here it is, atomic number 34. So this is going to be a doozy. We have to go all the way from number 1 to number 34, and you need to list where everything is. So first you go across. Do you have 1s2? Yep. And you've got this 2s, etc., etc. You're going all the way until 34. So let's list those things. You've got first energy level, S, and you have 2 squares. So 1s, 2. In the second energy level, or the second period across on the periodic table, you have 2s and you have 2 squares. And then you go across here, you're still in the second energy level, so it's 2, but now you're in P, so it's 2P, and you have 1, 2, 3, 4, 5, 6, 2P6. Okay, this gets you 10. You need to go to 34. So you jump down here. Third energy level, S block, I have 1, 2 squares. Okay, go all the way across now. It's because you go from 11 to 12 to 13. So where's 13? 13's in the third energy level in a P block, so 3P. And how many do you have in 3P? Well, do you go all the way across? Yeah, you've got to get to 34, so you definitely have to go all the way through 18. So that's 3P, 1, 2, 3, 4, 5, 6, 6. Okay, that gets you to 18. And you can double check that too. Add up these superscripts. 2 plus 2 plus 6 plus 2 plus 6 is 18. That's not 34. So you have to keep going. After element 18 or electron 18, you move to 19. So this is in the fourth energy level in the S block. So you write 4s. In 4s, how many do you have? Well, you have both of them. In selenium, you have a 19th and a 20th electron. So you have to say I have 2 in 4s. After this, after electron 20, electron 21 is in the D block. And remember the D block, that center area, has that funky rule. Even though it's in the fourth period, it's actually the third energy level. So this is 3D. And don't forget, this also goes back to when we did the electron dorms, right? You filled the fourth suite before filling the third floor den. So you're going back now and filling the third floor den. The whole reason for that is the D shape is really, really complicated, so it squeezes up super tight. The energy level just says how far from the nucleus, so 3D takes more energy, but it's just really small. So that's why it's in the third energy level. All right, you go across and count how many do you have. And when you count these, you have 10. Okay, so 3D10. That brings you to electron 30. You have to get to 34, so you keep going. You go back to regular rules in the P block. So we're back to 4P. And how many do you have? 1, 2, 3, 4. Notice you don't finish, you don't have 6. You only go to electron 34. So there you go. That's selenium. Okay, so on your own, I want you to figure out the electron configuration for these 4 elements: fluorine, bromine, barium, and beryllium. So you're going to press pause on your video, do these on your own, and then check your work. If you get any wrong, then now is the time to talk to a teacher and see what happened, get things squared away before you're working on your worksheet. Okay, so freeze your video and we'll be back in a second. All right, here are the electron configurations for those 4 elements. Please pause the video so you can check and make sure what you got matches what this is. Remember, you need to read very carefully. If there's something you got wrong, now is the time to talk to a teacher. Okay, so get this done. Then you're going to work on the first few questions of your worksheet and then come back for the rest of the notes. All right, you should be done with problem 1 on your worksheet. So before you move on, you need to understand noble gas configuration. And what noble gas electron configuration has to do with is these things called noble gases. So noble gases are highlighted for you with the red right here. And you're like, oh my gosh, helium came back over to the right-hand side. It's there. It's still technically part of 1s, but since it's a noble gas, I used a picture that kept it on its normal side. And that's why helium is listed on the right-hand side, even though it fits characteristics here, but it doesn't. It's helium's funky. But anywho, what's a noble gas? So noble gases are these elements on the far right-hand side of the periodic table, so helium and down. And what makes noble gases so important is that typically, like 99.999% of the time, elements that are noble gases do not bond with other elements, and that's why they're called noble, right? Like noble, like kings and queens, they don't mix with the peasant folks, okay? So noble gases don't mix with the peasants of the other elements here. So neon isn't going to go bond with fluorine at all. So because these noble gases are not making bonds, then their electrons never change. Because electrons are what make bonds between atoms. The electrons change so that they can link up in funky ways. Since noble gases don't make bonds, their electrons never change their configuration, or the electrons are always found in the same general area of the atom. So when you're doing electron notation, you can abbreviate the electron configuration. So that way, if I'm like, oh, hey guys, why don't you write the electron configuration of hafnium over here? You're not, oh my gosh, freaking out. You can just, there's a way to shorten it and you don't have to list all those 1s2, 2s2, 2p6, blah, blah, blah. So you do that by writing a symbol for the noble gas in brackets in place of that element's electrons. Let me show you what I mean. So what's the electron configuration for cesium? So cesium is right here. So its electron configuration is all of that. I'm not going to say it. Okay. Xenon is over here. Xenon is a noble gas, and it has this configuration. Now, if you notice, there's something very similar about these two. Xenon's electron configuration from 1s2 all the way to 5p6, so all of those electrons are included up here. So I can abbreviate this cesium to be Xe for those 56 electrons in xenon, and then 6s1. This is cesium. Okay, this is an abbreviated way to write the electron configuration of cesium, and it's a heck of a lot shorter than that whole long thing that I had on the last slide. So the first thing you need to do is work backwards on the periodic table and find the last noble gas to fill before that the element that you want. Write the symbol of that noble gas in brackets, and then list all the extra electrons found in your desired element that are not in the noble gas after that. Okay, what do I mean? Calcium. So I've gone back to my old periodic table with the numbers, but you have a regular periodic table with the names in front of you, so you can use both of them. So where is calcium? So it's right here, atomic number 20. So if I work backwards, then the last noble gas is here, and that's neon. Okay, so let's do an example. Let's do the noble gas electron configuration for calcium. So the first thing you need to do is find calcium on your periodic table. I know I switched back to my number periodic table, but you should have a regular periodic table in front of you. So calcium is atomic number 20. So here's calcium. So if I work backwards, what's the last noble gas listed before 20? So you kind of read backwards. So go 19 and then 18. It's, these guys here. And 2 would count too, but so 2's here. So 18 is the last noble gas, okay? That's argon. So when I put AR in brackets, and remember, you can only do the noble gases in brackets. Don't put any other element, only these guys. These guys are really special and handy dandy, fancy schmancy. You can't put any other element in brackets or it's just like weird. Okay, so what this means is in calcium, it has the same electron configuration as argon plus a couple more electrons. So when you see argon in brackets, AR, then you see, okay, argon is atomic number 18, so this accounts for calcium's first 18 electrons. But calcium has 20, so where are those extra 2 electrons? Well, they're right here, right? They're in 4s, and I have 2 squares, so 4s2, and you're done. You've written the electron configuration for calcium. Let's do another one, phosphorus. Where's phosphorus? Here we go. So phosphorus is atomic number 15. So you work backwards to find the previously mentioned noble gas. Here it is. So that's neon, Ne. So you can list Ne, because that's a noble gas, and that says, hey, the first 10 electrons in phosphorus are exactly like neon. So what else do you have? Well, read across. 3s2 and then 3p3. All right, best of luck with the rest of electron configuration. Be sure you talk to your teacher if you have any questions, and I'll see you in the next video.